Okay, so we're back again. Another reminder, if you want an index to these videos and other links that are associated with stuff we do, look in the description below under the video and you'll see stuff there. And then if you go to the index for these videos that I created, the text, HTML based index, it's got every one there. It's got the links are included there too. So one of the things I ran into this week, I was thinking about, first I was looking on the Homebrew Robotics web page, and they started posting pictures from the San Francisco Maker Faire that happened last weekend. And I just looking through the pictures on a random table, people were selling robots, and they showed a robot kit, and it was kind of like a triangular printed circuit board that had motors and omni wheels bolted onto it, and on the top it had a little plug-in processor. So it kind of looked like that, a little processor board that's plugged into a socket on top. And I noticed it was a short board, so it was like a Teensy 3.2, that size of a board. But you could see the socket pins ran out further than that, and I thought, that's pretty clever. If you could just build something so you just, if you want, you can plug in the small processor or unplug that and plug in the bigger processor. If you can find multiple processors, or you can find two processors that are different sizes and have the same pinout. Because it doesn't do you any good to go from one brand to another and find out that if you plug it in, now your power's in the wrong spot, and it can get ugly real quick that way. So I was looking at that and thought, well, what about if you use the Teensy boards? Because those seem to be really well designed, really well engineered, and as far as I know, they seem to work for everybody. And so let's go to screen 2. And so Teensy has a whole bunch of boards here. They got their newest ones are the 4.0 and the 4.1, and you can see one is a lot longer than the other one. And then they originally had the 3.2, and then he came up with the 3.5 and 3.6. Now I was thinking that the 3.2 and the 3.5 are very close to each other. So I was going to go check out the pinout on that to see if I could, just do that trick where you've got the short board put in, and though if you run out of IO space or run out of IO pins, you pull that out and you put in the bigger chip. So when I went to look this stuff up here, let me see if they. Well, let's do it this way. The trick is on the 3.2 and the 4.0. If you look at the actual board, let me do this, and I'll give it back to the big red thing. So here's the thing. It's got like 20 to maybe it's like a 24 pin package. I'm not gonna stop and count them up, but it's got like a 24 pin package, and then he's got along the end, these are some more IO pins you can connect to on the end down here. And then if you flip it over, there's a bunch of pins on the back, so pads, so you can solder wires on these pads on the back. And that, if you absolutely have to, you can do that, but don't do like I did one time. I soldered a Teensy 3.2 down to a perf board, and now it's there permanently. I can't pull it off and get to those wires on the back. But if you had to, you could use these wires on the back. But if you go to the bigger one, the Teensy 3. No, which one did I just have up? That was a 3.2, I think. So we go to the 3.5. It turns out, well, it's got simply has a lot more IO pins on the end here. I see you still got more pins on the back. So again, if you wanted to, if this is not enough IO for you, you can flip it over and you can still solder wires on the back. And again, if it's something where you're going to unplug it and plug another one in, that it's not real handy having wires soldered on the back. So if you can just get a board that will fit and work, you'd be better off. So I was going to go through the trouble of comparing this board to this board and see, what the differences were between the two. But as soon as I pulled up this board for the 3.2, I noticed it says not recommended for new designs or projects. And he explains that he's having a hard time getting the chips for these boards. And he says it's going to be even harder in the future, and they're going to get real expensive. So he suggests you just switch over to the 4.0 and 4.1 instead. And I didn't know any of this was going on, but you look down here and he's got a timeline. He says, oh, this one group had 80 boards in stock, and these had these. And he gets down to the point, it says, there are no more boards. So he stopped creating these boards to start with. And then the distributors, see, you look down here, his inventory status is out of stock as of October 9th, 2023. So a year ago, he was out of stock on these, and you could probably still buy them both through other places. You might be able to get them through Adafruit if they bought up a bunch of them. But you know, if this happened a year ago, these may have all gone away. So that's the first thing I noticed was rather than using a Teensy 3.2, or if you go to the 3.5, it also says the same thing. They're out of stock. So I thought, well, there's no sense designing something new. As they say, not for new designs, but you know, I got a bunch of them laying around. I could use them for my own purpose. And the whole reason I bought that 3.5 was for my remote control box, and because I've got an Adafruit board in there right now that's got the some kind of ARM processor and a radio all in the same board, and I put that in and started wiring stuff up to it. And Adafruit likes to put stuff like battery chargers and all kinds of extra stuff on it, so the number of pins there you have you can't actually use. And so I thought, well, I could switch to a different part. So I could go to a Teensy 3.2 and put an external radio on it. I thought, well, if I'm going to do that, I may as well just go to the 3.5. So I get tons of IO and put a radio on that. So that's where I was going to use that board. So I could still go ahead and do that, or I could just, you know, grab another random processor. Again, here's just a random processor you can buy for $3 to $5 on Amazon, and it's, you know, a fairly fast ARM processor. It doesn't have the radio, so you'd have to add the external radio if I wanted to do that. And I program with the ST Micro IDE and use this little programming adapter that you can buy for $3 to $10 on Amazon, depending how you buy it and when you buy it. So that's the first tip off I had, that, oh, they don't make these anymore. So let me go back to my screen here. And then let's see, TC 3.5. So then if we move up to, well, let's go back to that list, just because it's real cute list. So here's all these boards here. So I went to look at the 4.0 and the 4.1. And when I started pulling those up and looking at them, I think it's this one. So here's the 4.0, and you know, they give you these cute little charts so you can see what all the stuff is. So if you compare this board, let's see, how did I do that yesterday? I think I did. This one. Stop it. Oh, it's trying to help me again. So I'll bring this over here. Do like this. Do this like this. This one. And it turns out if you go look at these, if you look at the first pins here where it goes, we can look at this one that says 13, because the 13 shows up in the middle of the page over here. But everything from here over to here, if you compare everything, they seem to be almost identical. And the ones on the bottom, again, if you go for the one that says 12, so this whole block here, this seems to be almost identical to the one on the big one seems to be almost identical to the small one. And the differences I noticed was right here on the big one, they've got an extra SPI port that they stuck in there. And it turns out that actually shows up somewhere else too. It is 0, it's a 1 over here. So right here it says CS1 and MISO1. Those actually show up over here too. And I think by looking at it, it looks like these are darker than these. So this is probably the alternate pin concept, where by default it shows up here. If you say turn that peripheral on, it shows up on these pins. But if you wanted to use this CAN interface instead, you can change the alternate pins. You can use these two wires to do that. But the differences I noticed was these two pins are there, but if you wanted to, you could go up here and use these instead. And then there was one up here that was different. I don't see which ones they were, but So there, I think I found two pins that look like they're different, but they're just simply, I think, the alternate pin kind of thing. So if you wanted to, you could start with this. So you put in a socket that's big enough to hold this large chip here, and then just plug this shorter board into that socket and leave the other pins open. And then if you decide you run out of space and you don't want to use solder the pins on the back, you can pop this board out and pop the big one in. So all the wiring and all the connectors you've done will still work with the big board because all the peripherals and all everything's still in the same order in the same place. And then it gives you an extra 18 digital IO pins, or if you want to use them as analog, it gives you an extra 8 analog pins. And then it's got here's an extra, looks like 3 extra UARTs on those extra pins. So you just have to pick and choose and decide if you want to do that. But anyway, I thought that was a clever concept. That did I finish my original story? I saw this picture on Homebrew Robotics. I went and looked it up, and it was that triangular shaped robot, and it had the socket on there for a short processor. And then it looked like it had extra pins. So I wanted to track that up. So I was looking at this, and it looks like, yes, you could do that. Here's at least one manufacturer that gives you the option to do that. So while I was looking at it, the first thing I noticed was it said, oh, by the way, these are going away. So that was the first thing I noticed, is not recommended for new design. So that's why I was looking at the 4.0, the 4.1 harder. So we come here. So for the 4.1, what's helping me out again? And this is giving you pricing on it. So if you want to get the 4.1, this is the larger of the ones, and you can either buy it with or without an Ethernet chip on the board. And if you buy it with the Ethernet chip for about $2 more, then you can also buy a little external adapter that's got an Ethernet connector on a little printed circuit board and a little flat cable that plugs into the board. So theoretically, this big board will actually allow you to run Ethernet directly, so you don't have to use the USB. So to talk this, you could use the USB. It's got like 6 UARTs on the board, and then it's got the Ethernet if you want to go down that path. If anybody's ever tried that, I'd like to hear back on how well that works, because I don't know. You know, as Al says, how much memory space does it take? And my thought is, you know, how kludgy is it, and is it worth adding, you know, tons and tons of software just to be able to send messages back and forth over Ethernet as opposed to USB? And it might be, because I think these come with a lot of RAM. Somewhere there's a table here. Was it this one? Specifications. Okay, so on this one, how come somewhere's got a table of all their processors, and somewhere it'll tell you how much memory the thing has, and hardware. Let's try hardware. Here we go. So processor core, blah blah blah, RAM. So right here, so this here, let's put this at, oh come on, how come I can't grab that? Oh, I know, it's off the bottom of the screen. Okay, let's try this again. So bring this up here. So there's RAM right there, and we go over to the, so both of them have 1 megabyte of RAM on this chip, which to me, that's just amazing that, you know, microcontrollers can have that much RAM. And then flash memory bandwidth. So flash memory is this one. We come over here and you can get them as kbytes. So so the little one's got 2 megabytes of 2 megabytes of flash, and the big one's got 8 megabytes of flash. That's absolutely incredible. So, you know, as far as having enough code space to run your Ethernet, there's probably plenty of code space there. Another interesting point, it'll run if you want the FPU, is that floating point unit. Some of these don't have it at all, and then you get up here to the 4.0 and the 4.1. This one's got the built-in. It looks like both of them have 32-bit or 64-bit hardware floating point built in, and all the older ones only have 32-bit hardware floating point. So it's a really interesting chip, and if you buy it directly from PJRC, they're not really all that expensive. They're like $30 for the board. And with or without Ethernet, it costs you a couple bucks more to get the Ethernet chip, and then like $5 for the external Ethernet adapter board. So that's something I found out about Teensys, and I've been putting off buying any of the 4.X parts simply because they are big and fast, and I figured they were a lot more expensive, but it turns out they're not much more expensive what the original 3.2 or the 3.5 were. And you know, the fact that the big one can actually do full Ethernet if you want, and it's got incredible amounts of flash and RAM, and they run at 600 megahertz, so they're pretty darn fast. There's probably lots of other fancy options. You have to be careful on these because I think other than like I think the 3.2, it said it had 5-volt tolerant inputs on it, and the 3.5 had 5-volt tolerant inputs, but the 3.6 did not. And I believe it says the 4.0 and the 4.1 do not. So you're going to have to add some kind of external level translation if you're trying to run 5-volt. If you're trying to put 5 volts into it, you need to translate that externally. But in general, it looks like you know, they got a good enough reputation. I wouldn't hesitate to buy these if I decide I need something yet new and different. I probably wouldn't hesitate to buy one of these. So what's the other things I was looking at? Oh, it's helping me again. So this, you know, I was just simply they've got the nice cards here that shows you what all the pins are doing, and that's handy when you go to hook stuff up. And let's see. Okay, before I move on here, as I was looking at this and I see I believe it looks like even the Teensy 4.0, is that the board we got here? Yeah, 4.0, it has 2 CAN peripherals built into it. There's a CRX1 and CRX2. So if you ever want to run CAN, this has the CAN peripheral built in. And if you go to the bigger one, the 4.1, I think it also has two. So that one is so this one is CAN and this one is CAN. Maybe that was the difference I saw in it. This one right here, it says CRX1. I don't think that's over here. Yeah, that was the other difference. That's I said there's two pin differences. There's one there that's different, and the one down here is different. But you know, you can move them around, and that it should still work. So I think for the most part, you can say these are directly interchangeable if you want to do that with a small board or the big board. Now, as I was saying, both of these boards seem to have 2 CAN peripherals built in. So what I was noticing was I was going back and looking at my little boards I buy on Amazon, and the blue pill board, which is like a $3 processor, and it's got an F103 processor on it, and that one has 1 built-in CAN peripheral. And I was able to get that to talk. I had a bunch of stuff on the table here one day, and you put an external transceiver. It's like a $3 to $5 chip. It's a CAN transceiver, and you put a little bit of code in it, and you can get that to talk as a CAN bus. And then I was noticing this one that you can buy on Amazon for say $3 to $5 is but probably handy if I just turn my background off. Put it down here. Anyway, this board is like a $3 to $5 board, and it's got the F401 processor, and it does not have CAN built in. And then you get another one that's similar to this that's got the F411. And I thought, well, basically it's just a faster processor with more flash and more RAM. It also does not have a CAN interface. But if you go up to the big one, I think it's a F407 GT or something. This is the one that's on my mini tractor right there right now. And this one has 2 CAN peripherals built in. So you know, again, depending on what you're going to use, you have to go look at all the specs before you invest all your time and money in it and say, well, I want to use this, and then find out, oh, it's not going to work. So, but you have the option of taking, say, one like this, and this could talk to your over USB. This could talk to your main computer, and do whatever you want. But if you need CAN, then you could use the concept of the smart peripheral and add one of these other chips. So you just add that chip with the CAN interface and just have like a 2-wire interface between the two boards to communicate. So you'd build, this could be your main computer. And you could actually mix and match this stuff. I can put an Arduino on as the main one, and this is a slave board. So there's lots of options that you can do to make that stuff work. But that's something I noticed that what I considered the older, cheaper chip has the CAN peripheral, but the next two up the line that I can buy on Amazon do not have that built in. But then you get up to the next bigger one, and it's got two interfaces built in. So that's just something that I happened to notice when I was digging through stuff the other day. So before I move on to the next concepts, any questions about the Teensy stuff? And I didn't make any decisions on the Teensy. I was just looking at this stuff and deciding, I'm sure they would work if I need something that's way too fast and has way too much room. But it's getting to the point where if they're no more expensive than the crappier ones, you may as well, if you're buying something new, you may as well get a big one unless there's some specific reason not to do that.
Yeah, no questions for me. I mean, I'll just comment. I've used Teensys before and have one of the 3.2s on my current tractor, and I've always been impressed with their speed and performance and whatnot. So I haven't bought a 4.0 yet, but it might be in the future.
Yeah, I currently have two of the 3.2s on this vehicle here. I don't know what that is on the front in this picture, but currently it's got a piece of plastic across there with two proto boards, and each proto board has a Teensy 3.2, and one's got the B&O 55 IMU, and then it's got the B&O 85 IMU. So I'm using two of them there to do that, which any processor would do that. And then actually on mine down here, there's a Arduino Nano down here just to read the steering feedback from the RC server on the steering. And then inside of this box here is my remote control receiver. And that one, I had the Adafruit board, but that particular processor did not have the CAN bus. And I wanted CAN on this simply because I was trying to duplicate the remote control we had at work. So it turns out I put a 3.2 on that because the 3.2 has the built-in CAN interface. And I got that to work. So there are 3 Teensys on this thing, and they all seem to do what they're supposed to. So that I was really happy with them, but they were more expensive. If I could buy a board for $3 or buy a board for $25 to $30, if I'm not doing anything special, I'd rather buy the cheaper boards. So of course, there's something to be said for if all the boards you use are the same brand and even the same model. That way, your development software, you don't have to have 5 or 6 different pieces of development software to talk to all the different boards. So that just keep that in mind too,
I agree with that.
as you work on the stuff. And even a point on that, if you go with the Arduino IDE, you can get plugins for all these different processors. So that helps out a lot right there. But when I went to this ST Micro stuff, I went to their big proprietary development system. So doesn't run with Arduino, but I had been using that before, so I already knew how it worked, and I could make it work. So just more cute little tips for people that are thinking about this stuff. Okay, my next concept was, again, I was sitting around, along the same stuff that I was just talking about. I was looking at different, say if you wanted to make a board and make it maybe more universal or whatever, you may end up with something like this where you've got just a piece of perf board, and this happens to be one of those $3 blue pill boards just stuck in there as an example. So then I could put connectors out here to wire up to everything, because most of the stuff I do, I just run wires from this board down to a connector and solder it on, and from here down to a connector and solder it on, and that works out fairly well. I just thinking, how could you get, say, a more universal board? So how would I make a connector that's useful for maybe useful for more than one thing? And I was thinking about examples of other things that exist. And one example is I think Adafruit originally designed this board. It's a it's a board. It's got this, what is it? PCA 9685 is the chip that's on it. So it's an I squared C to 16 channel PWM generator chip. So it's got on the left here, you've got I squared C interface, you got some power and ground to run the thing. And there's, I see it's got an output enable. And then on the other end, you've got the same wire. So they run all the way across. So you can daisy chain these boards together if you want to. And then over here, they're talking about I squared C address. So if you're going to put more than one board on the same I squared C line, you can change these resistors, and then that makes this say board 0, and the next one would be board 1, the next would be board 2. I don't know how many you can put on there, but that's the concept behind that. So the I squared C talks to this chip in the middle, and the chip has 16 output pins that you can generate a 12-bit PWM on those. And they're somewhat programmable. I can't remember if you have to run them all at the same frequency, or if you could have half of them at the frequency to run RC servos and the other half to run a frequency to run, say DC motors. You'd have to look at it. That's really not, that's not why I pulled this thing up, but I was just going to point out the flexibility of how you connect these things. So here they've got this chip on here, and then each signal pin has a resistor in series with it. So from the chip here, it comes out and connects to, say, this resistor, and then this resistor connects to this this pin right here. This is a PWM pin. And the thing that I don't know if they said this is the reason, but if you want to, then you can connect an LED directly from this PWM pin to ground and drive it directly, because you already have a current limiting resistor in series with it, the way they laid this out. Or if you want to, you can flip the resistor around and go from the PWM pin to the power pin. So you can do it either way. So that, and just that right, that gives you a tip on the flexibility right here, that you've got a connector. These 3 pins form channel 7 on this thing. And you've got a ground pin, a power pin, and a PWM pin. And what they did, they just laid them out across here. So if you go look at the board, there's, I think you have to look at the back of this one. There's a bus that runs all the way across here for the ground. So all those pins on the bottom are all connected to the same ground bus. And the next one up, you can see right there, there's a trace, there's the trace. And I guess you can't see it there. So anyway, the 3 in the middle, or the pins across the middle here are all connected to this V plus line. And then you've got V plus at this end and V plus at this end. And that way you can separate that out. So if you want to run RC servers on this, you can plug in, whatever, you can plug in a bigger power supply and probably a different voltage power supply than what the board is running at. So, they usually say RC servers run from 4.8 volts up to 6 volts. So you can put, a 6-volt battery, or like a NiCad or whatever battery on here to directly run your RC servos. But I think once you hook this up, I think that means all these pins across there will have the same voltage on. If you wanted to, you could connect this V plus to VCC. So if the board is running at 3.3 volts, you could connect those two together. And that means this middle rail would be 3.3 volts. Or you could connect the V plus to 5 volts and you have 5 volts across there. Or connect to 12 volts, you have 12 volts across there. You just have to look at your application. And that's a little more flexibility they give you there, in the fact that you can select your power that's going out to that thing. And the other point was, so the way it's laid out here, we'll go to the middle and see the number here. So it's this is channel 4, you get 3 pins, you get power, ground, and signal. Channel 6, you get power, ground, and signal all the way across. So when you're writing the software, you say go out to, say, channel 5 and set the PWM to this value, and it generates the signal there. So somewhere, I think you can look at the Adafruit website for one of these type of boards. I think they got a little movie running where they got 16 servos laying on the table, all plugged into this thing, and they're all, moving in different patterns, just to give you an idea, what you could do with this. But you don't have to use it for RC servos, because you can program these for, you can set the frequency to, was it 50 or 60 hertz that RC servos like, and then you can program the pulse that it's putting out to be 1 to 2 milliseconds. So that way you can program it to run RC servos, or you can program it to run 0 to 100% PWM. So if you want to run DC motors with it, or you want to run an LED with it, you might want 0 to 100%. So there's a lot of flexibility on what this type of board gives you. And I was just noticing, so I was, what's this green connector up here? Well, see, it's got the V plus bus across here. It's got the V plus pin here, V plus pin here. It also comes up here. You can put in, you know, a big wire into the V plus there and have a big ground wire coming in. So you can hook up to a battery or whatever. You can do that. So it's just more flexibility they put on this board. So what I really want to point out is you can put these blocks of pins here, and then if you got something like so on the RC servo, you know, it's got the 3-pin connector there. And be careful when you look at your RC servo before you plug it in, because this one happens to go ground, power, and signal. And that's what that little board wants. But at least one of the brands, they've swapped the wires around. So make sure you look at it before you plug it in to make sure you've got the right one, you know, for what you're trying to do. So you don't hook the power up backwards, or they might have put power on the signal line or something. So that was a minor point there to look at. Go back here. And then the next point was, you know, if you're trying to come up with this sort of a universal connector scheme where you've got here, they got, you know, 4x3 blocks of pins. And one thing, the next thing is handy is somebody, and I don't remember what the Adafruit ones look like. I should have pulled up the Adafruit page. So what this company did, when you got by these header pins, you can get them. You can buy them with the black plastic, the red plastic, or yellow plastic. You can probably even get yellow and blue, whatever. So they just simply got different colors. So the ground across the bottom they're black, which is somewhat intuitive, and then you got the red ones are power, and then the yellow ones are signal. So if you happen to have a case where you can have 2 signal lines, you could have one be yellow and one be green, or just something that, you know, they're different colors. So it's as you go to plug it in, it's more obvious where stuff has to go here. But as far as I know, this board is, you know, exactly the same one. I think Adafruit designed this, and then they designed it, they made it open source. So the Chinese people go out and just grab all the design files and start cranking off boards and selling them for a lower price. And something that we noticed just before, hold on a second here. Monkeying with my screen here and it's not playing the game. Something we noticed just before that is, here's the 2 boards. And the one that's got the colorful connectors on it, which is the ones I bought some of these. They're $8.99 a piece. If you look over here, it says $8.99. And so you got to be careful. Sometimes it says, "Oh, do you want to get not? I think you go subscription, or once a month they will send you a new one or whatever, and they're a little bit cheaper. But anyway, for a single one, it's $8.99 and free shipping if you have the Amazon Prime. And the one that doesn't have the color connectors, well, they're $12.99, so it's $4 more for this board, and you still get free delivery. But so that goes back to the moral: if you're going to do something on Amazon or eBay or wherever, you know, find what you want, and then find everybody else that's selling it, and find out, you know, can you get a better deal, or in this case, you can either get colorful connectors or not colorful connectors. So that's just more things to consider there. But I really just wanted to show the connector scheme here, that, you know, you could lay them out like that. And then where's my grab this board that I was just showing Al before the meeting. I have to turn off this. Sharing. So this is a board that was on my green robot, and this is just a panel that I made to put on the side to put all my electronics on. And seeing there's 2 of the old Radio Shack perf boards on here. It's got like some aluminum brackets. Can you see on the end here? Wrong in the board. There we go. So see, it's got the 2 boards are hooked onto these aluminum brackets, and then they're held down with standoffs. And you can see there's some wires on the back, not a lot of them. And then the board itself, that's screwed down to a piece of plastic. And then on both the front and the back, I've got some aluminum angles. So the whole thing would just simply bolt to the side of the box. But the whole point was, at the top here, it's got this board, and I don't remember what these are called. I thought it was the Mini-Robomind board, but it turns out it's not. And I've got a couple of these boards, and I know Terry's got a couple of these boards, but this had a Motorola 6832 processor. So it's like a Motorola 68,000, but it was, I think an automotive version is what it was for. And then it's got this either 64K or 128K RAM chip on it. And then up here, the point is it's got this big block of connectors here. And these seem to be 4 pins each. And there's, I don't know, 8 to 10 to 12 channels across. And I think the point on this one is they are heavy on SPI interfaces. And SPI has what, MISO, MOSI, clock, and then a chip select. So this way you can have, a 4-wire cable coming in and plug into whichever SPI channel you wanted here to talk to the thing. And the other board that I can't find, which I haven't looked for very hard. It took me 5 minutes to find this one. But here's a case where somebody's put enough thought into this stuff. They came up with this concept where you got a block of pins, and then you can plug in those either the individual jumper wires, or like on the RC servo where it's got the built-in 3-pin connector. I can't talk anymore. I may have to move on here. Where's my juice?
Yeah, where's your Mountain Dew?
So I just wanted to show that, people have given this some thought. And if I can find that other board, I can present that next time and show what that is. It was an old enough board. I don't know if I can find online documentation for it. Or if I can find the physical board, I can just hold it up and show it. And it was a chip, and the whole board was covered with little connector pins, and they had them laid out in nice blocks, nice logical blocks. And I was just thinking that would be a good way. So if you had a board like this and just, had rows and blocks of things down here. So say this block of pins might be analog, this block of pins might be UARTs, this block of pin might be quadrature decoders, and so forth down the line. And then if you decide you need an IO pin, you can still use those. Just take the say if I declare it as a quadrature encoder, it's going to have 2 data lines on there that go to specific pins on the board. But if I need those pins, I can just not program that for quadrature and say those are digital pins or those are analog pins, and just go ahead and hook wires up to them and use them anyway. So it'd be the fact that you can make a board like this, and if you get it so it all makes sense, then you can make a printed circuit board. So you just buy one of these $3 modules and plug in, and it would have all the patterns for connectors, so you can solder the connectors down. And if you decide you need to go to the slave processor concept, where I've got, say, this board is my master and this board's going to be my slave board, all you got to do is run like a 2-wire cable between the 2 boards to get the 2 to talk to each other. So I'm just thinking down the line, what would make sense there, and without making everything custom every time. Is there just a decent way to come up with that? So that's I think that's all I have at the moment. So I'm just thinking about how do I make standardized connectors, and how can you do it without wasting a lot of time. And I certainly don't want to have to rewire boards, every time I make a change. Oh, I got to throw this board away and start with a new board and put all new connectors, all new wires, move it around to get a little more space or whatever. So I was just thinking about that stuff.
Very neat. I was looking at that PWM breakout board that you pulled up and thinking, oh my gosh, I would never have the need for 16 channels. And then I'm remembering, I think Ag Open GPS, one of the use cases is sprayers, and they get these boom sprayers out there. And I don't know, the number is 12 is coming to me, but don't hold me to that. I mean, the sprayers all have pumps, and they can control the various pumps based on where they have sprayed and where they haven't sprayed. So yeah, there's some applications that could use all of that. And then you mentioned controlling an LED, and I thought, oh yeah, that would be for indicator lights and different things. You could end up needing a fair number of channels.
Yeah, you can burn up IO very quickly. So you say you didn't know you need that many. Well, here's the Teensy 3 or the Teensy 4.0 across the bottom. These are all PWM pins on that. So even without adding the external board, you can get a ton of PWM there, and they got more across the top you could do by using just the Teensy 4.0. But it's also handy if you want to just offload that stuff from the processor onto something else, because you just write the data out to that little board that we were just looking at, and it sets the PWM, and it'll hold that until you change it again. So basically you're offloading all that stuff from the processor. You just send out some commands over I2C and set up the channels and they do what you tell them to. So, but even, modern processors have tons of PWM coming out, but if you use that PWM pin, you can't use the other functions that are on it. So that's just more things. It's a trade-off, between the things.
Cool.
And, you say that it seems like way too many, but once you start using them, boy, you start chewing these things up fast. So it's just one of those things. Okay, so I'm done.
Well, on my side of the house, not much robotic stuff to talk about, but I'll talk about some sort of tangential things. They say start with a picture to tell 1,000 words. I've got a NAS drive here that, let's see if you can see that. And let me get a little closer without tearing something up. So that is a Synology NAS drive, and you're going to say, well, where's the top of it? Well, I had to take the top off because see where that blue light is? It's actually a switch embedded in the blue light. And I've had this NAS drive for so long that the LED, around the LED is a plastic
Uh,
sort of
can you turn your screen sharing off while you're showing that?
turn screen sharing off, stop share. Um, so around that blue LED was actually a plastic shroud that would go in and out for the on-off button. And the Synology drive is probably 8 or 9 years old, maybe 10, and it finally that plastic deteriorated for some reason, and so I couldn't get it turned off and on, and so now it's on, and I could figure out the wiring and probably jump it, but it's like it's getting time. The OS, they're not providing any more updates for the OS, and so I started looking around for my next NAS solution, and I think that's at the moment that's got 2 spinning hard drives on it, maybe a total of 4 terabytes, but it's RAID, so I think I have 2.7 terabytes of usable space. And let's see, so I found there's an outfit that makes a hat for a Raspberry Pi 5 that will let you put in parallel 4 NVMe SSDs. And I'm like, well, that's a pretty cool solution. But you have to have a Pi 5 to run it because they have this ribbon cable that comes down here with the PCIe. Is it called PCIe, I think? So it's got a PCIe connector between the hat and the RPi 5, and then power for it from that Lightning C connector. And there's an open source NAS software that can run on the Raspberry Pi. And so I went cheap. We'll see how that turns out. But AliExpress has 2 terabyte NVMe boards for less than $40 a piece. So I've ordered 4 of those. This has arrived. This hasn't arrived yet, but the game plan is to try to make a low cost, low power, small form factor NAS drive to replace my Synology, let's call it 10-year-old Synology NAS drive with about twice as much twice as much space. Because all in, this is, $90, $160, $50. Just the case, just the Synology case is like $300, I think, $400. So anyway, if this works, I'll save a few dollars, have a little bit more space, and be able to run other stuff on this. Like if I put this right at the what do you call it? I'm going to say point of entry, but where broadband comes into the house or fiber comes into the house, I could put. You've talked before about ad blockers. I could probably run an ad blocker on this, or a VPN or something else in addition to it being a NAS drive. Anyway, so that's a little bit robot related, because I store clones of my laptop on this NAS drive. It's a big user of space. Thoughts or comments on that?
So this setup also is a RAID, so you got multiple copies of stuff out there.
Yeah, the open source software will let you run it in like RAID 0 through 5, I think. So you would have multiple copies, which is part of the reason why I thought, I'll buy this low cost SSD, and hopefully RAID will protect me.
Do you have much experience buying flash type things on AliExpress? I just seems like people are notorious about selling fake parts, for like flash, like thumb drives and maybe these SSD drives. I don't know. I'm just curious if you've run into any problems with that.
I haven't run into any problems, and I bought a few things from them. I bought one of these. It's a little like is it 250 gigabyte drives, and I had good luck with that size drive. That would happen to be put Ubuntu on there. We'll see. I may be might get educated and have to go a different route for the actual storage. The other thing, let's see, something else I just wanted to mention. Behind me, you can see, well, I'll turn sharing off here so you can see it a little bit better. I've been trying to clean out stuff, and better turn it that way. And so I've had these are LiPo for lithium. Well, they're LiPo batteries, and there's 4 of them here. 1, 2, 3, 4. And I've had them sitting around literally for 2 years, maybe. And I knew I was going to do something with them, but I never quite knew what. So, like, hey, I'm either going to use them or I'm going to get rid of them. And so I grabbed my 12 volt what do you call these things? Inverters. Just a small little inverter, maybe 80 watts, 90 watts. And I'm like, well, I'm going to get a BMS and hook these up and make that a 12 volt to 110, small little deal. And I got a battery box to put it in, so it's pretty well protected. And that's the other thing I've been poking around with. So that, I don't know, wherever if I need 110, a portable 110, those are 120 amp hour batteries. So that will give me a little bit of leeway. Part of what got me started on that is I've got a cyber power UPS sitting behind me here too, and originally I was thinking, hey, I'll have, because you mentioned a couple weeks ago or maybe a week ago that you had a UPS that you changed or you added batteries to it. I'm going to ask you a question about that, but 1 second, I'm going to grab the battery. So I thought, actually, what I originally thought was I was going to use those blue LiPo batteries to be my stand, my external batteries for my UPS. And then I started looking at a video for the darn UPS, and they've got these darn things running serial, so, or series, and two 12 volt 9 amp batteries in series. So I'm like, oh crap, I didn't realize that was a 24 volt system. So anyway, I still have to figure out what to do about replacing my UPS batteries because I don't have 24 volt or enough. I don't have 8 cells. So what kind of batteries did you put externally in your UPS?
I was muted. It had whatever the one that came in, it was a lead acid battery. So it was like a 7 amp hour. You know, it's an APC something.
Yeah, that was the original.
So that was that it's a UPS 500. I don't know what that means, but anyway, it had the battery inside, and I had this other robot battery laying around. It's like twice the size, so it won't fit inside. I just simply have it in the back, and the wires that normally came out and hooked onto the original battery, I just laid the other battery on the table and hooked it up to it, and that seems to work. And you might think, well, gee, I could put a monster battery on that. One time I was playing with some UPSs that I don't know where they came from, but I thought I'll use that concept. And the UPS is a little too smart for its own good. It said, oh, I know I've got a 7 amp hour battery, therefore I'm only going to run a certain amount of time before I shut down. So even if you put a giant battery on, it still would just ignore the fact that it's a giant battery, and it didn't work out well for me.
How darn.
This one so far, I don't think it's complained. This might have an interface on the back. I could hook it up to the computer and have it tell me things, but I've never tried that. I just simply turn it on and it works. So I've been happy with that for the moment.
So was your battery a 12 volt battery? It's a 12 volt system or a 24 volt system?
This one's a 12 volt system, so it just
Mm.
had a single battery inside of it, and the one I had laying around this, I had a pair of these bigger ones, and one of them that they're so old, one of them had died completely, and this one still had a charge on it, and I hooked it up and it's working. And I should buy a newer battery to get the right kind for it, or get another one like this to put on it.
Nice.
Or I could just take what I should do is take the battery out of this thing back here. It's got a 38 amp hour 12 volt battery in it, and it's probably 3 years old by now, but yeah, I could take that, just put it on the table or put it on the floor and wire that up to it. And this one replaced the 38 amp hour battery with two of these 15 amp hour, 15 or 18 amp hour, whatever they are, and make this into a 24 volt system, because I should have done that up front, but I didn't. So that's more things I could move around. And
Yeah, so I don't think I've concluded how I'm either just going to buy off the shelf replacement batteries for my UPS or figure out which style battery I want to get it up to 24 volts. But at the moment, now my UPS is still dead. Let's
yeah,
see.
yeah. On that note, be careful about mixing and matching battery types, because, as they say, the UPS can be fairly smart, and it might say, "Oh, that's out of range for what I'm looking for," and it won't take advantage of what you put on there in the first place. So, if I had a specific lead acid battery for it, you might be better off putting the same thing back in. But you could, if you've got something laying around, you could try something else and see what it does. And
Good point. Yeah, because it was the two 12 volts that so the OEM batteries are 9 amp hours. And I was thinking, hey, I'm going to bump that up. But now that I know that it might be smarter than that, that's a good thing to be worried about.
so that's something where you could check it ahead of time and say, well, if you got a bigger battery sitting around, just clip it on there and try it and run it and see how it acts and see if it complains about anything.
And yeah, this is share my screen again. That's the video. It's a CyberPower 1500, whatever that means, but it's got these two batteries. As I held those suckers up with this piece in the middle that does the connecting, it all fits very tight. So anyway, and then the last thing I was going to mention, I posted out on Slack, because I've got 2 or 3 machines that I'm dealing with here. It's always nice to be able to remote into my tractor, and I've played around with multiple remote access options, both paid and free. Real VNC is the paid version, and that, as you might guess, works really well. Then I tried tight VNC and wasn't able to get sound to pass through. I could have fought with it more, but I decided to look around for what other options, and I came up with these guys from No Machine, called No Machine, and they have an option for personal use, which is cool. So, and as long as it doesn't become for commercial use, you don't get access to technical support, but you do get free of charge, access to the base software. So that's worked out nice. And you download a client. This is what that user interface looks like. I've got 3 machines, an Ubuntu machine and 2 Windows machines at the moment, loaded into this. And then it's very, once you get set up and you get your IP addresses organized, it's very easy to share desktops and make use of this. So I'm a fan, and I'm not breaking any licensing laws at the moment, which is cool.
Can you open multiple machines at the same time on that? So you've got 3 machines listed. Could you actually open three separate windows so you have everything on the screen at once? Not that you want to do that. I'm just wondering if you have the possibility to do that.
I've done 2. So from one of these machines, I've opened both of these, and you got to sort of be careful about where you're at. But given one's Windows and one's Ubuntu, it's not too difficult to figure out where you're at.
Yeah, I find it's handy on at least the Linux machines. Put a different background on each one, at least like a different color background on your desktop, so that when you look at it, that'll give you a fairly good indication, unless you've got full screen and you can't see the background anyway.
Now, if you go back to their explanation, when you think where their software will limit you is if it says, do you need to share, it says your desktop with as many users as you like. So I didn't get into it, but I'm like, I think that would be like if you have one machine set up almost as a server and you have multiple people accessing that. I don't know how you do that at the same time, but yeah, they've got this sentence here that sort of draws a distinction about multi-user access. Anyway, this was a heck of a lot easier to use than tight VNC and then having a separate viewer. This is both a viewer and and I'll call it emulator at the same time. And that's all I got for today. I'm hoping to get out and do more testing. My guy where my robot is he's got some shift work going on, so we're gonna be out there at a social hour for him, so I'm not running the tractor when people are trying to sleep.
Yeah. It does bring up the concept of, can you quiet these things down? And I don't know. There's always the argument you can put as big a muffler on as you want, but if the engine itself is just making mechanical noises, you can't really, reduce the sound of it down to a certain, down to a reasonable level. So
You're right about that.
that's come up before, and I don't know. It seems like any of the manufacturers put on the smallest, cheapest muffler they can on whatever they're building. Because I'm sure they put out rules. It's always got to be under so many dB. So they're only going to put on whatever it takes to get that. And they don't really care, beyond that. So I don't know. The other day someone's I think they're running a leaf blower because our leaves are starting to fall. And I've gotten the habit of just waiting until they're all on the ground and then take them up. When they're all on the ground and then other neighbors are picking their stuff up, do it all at the same time because you can clean your yard up real nice. The wind blows, you get everybody else's leaves in your yard anyway. So
Too bad you don't have a robot to pick those up.
yeah, I was just thinking. Well, another thing, just totally unrelated to anything else we've been talking about. Uh, it'd be I think it'd be handy to put something on the front of a lawnmower, like a brush or something that's going around. So as you drive along, it picks the grass up. Because like right now, my yard, this picture right here is from years ago, but this is what my yard looks like right now, where it's all dried out and looks terrible. And I think most of what there is crabgrass, but it's all down flat and laying out flat. So you try to mow it, it won't stand up, and then you come and rake it, then you get all these weeds sticking up. And it just seems like if you had something on the front of the lawnmower that come by and rake it, comb it, and stand it up and then mow it off, that would be a handy thing to have. But I've never seen anybody doing that. I suppose you can even just put like a physical like wire type rake on the front that as you push it, uh, if you got to push more, it makes it harder to do because then you have to physically push that at the same time. But I don't know. And the other problem is my mower is a mulching mower as opposed to the kind that blows the stuff out the side, which means it doesn't create a vacuum to lift the grass up, even when the grass is growing right. It doesn't lift, suck the grass up to cut it off. So that's another problem, but that's just the way it goes.
Interesting.
And I'm not that much of a yard guy, so I don't really care too much. It's just annoying. You run the mower across it 2 or 3 times, and you still have this grass laying down that won't cut. So that I was just thinking about that the other day. I suppose I'll get out my big lawn tractor and mow everything. It does blow stuff out the side. So technically, I suppose if you get a bagging attachment, or I think some people put like an extra gasoline engine with a blower on it to basically make a vacuum cleaner to suck up stuff out of their yard. But I'm not going to buy a commercial one because I don't want to spend any money on it, and it's just like too much screwing around to try to build one from scratch right now. So that's just more things that I had thought about. So
Nice.
I don't think I have anything else for today.
I think that's it for recording.